Alright, good morning. This lesson is for my Trig-Precalc class. This is going to be for section 7.2. This is lesson number 1. But before I get started, I want to say I hope everyone's doing okay out there. And again, if there's anything I can help you out with, please reach out through the Remind app or through my email. And I'll get back to you as soon as possible. And again, let's make sure we're doing everything we need to do so when this semester is done, I can get you credit for this class. Our goal today is we're going to talk about Intro to Solving Linear Systems using Elimination. You've actually already done this back in 9th grade and probably in 10th grade. But it's a good, it's a good review because it's this math is it is relevant here. And I'll talk about that in a later lesson, how it can be used to drive decisions. But I want to introduce the concept of what we're going to do, the elimination concept, by telling you a story about a mathematician named Gauss. And Gauss is like legitimately one of, I guess to make you guys understand, to say in your terminology, he's a mathematical goat, okay? I remember in college, you have to go ask professors questions, and all my math professors, when I go visit them during office hours to ask questions about the lesson or about the homework, most of them had a picture of this guy who kind of looked like Robin Williams to me. And I kept wondering, like, why do they all have this poster? And I never really appreciated his skill and talent until I took a math history class, and my professor was talking about some of the mythology behind Gauss. One of the stories about Gauss was when he was 3 years old. I don't know if you know any 3-year-olds, but intellectually they're not very impressive. But at the age of 3, Gauss was able to find a mathematical calculation mistakes in his father's bookkeeping. And so I mean that's pretty impressive right there. So again, if you know a 3-year-old, it would be very easy to be astounded with the fact that one of them found a calculation mistake. The next mythology deals with Gauss. I've heard of 8 years old, 9 years old, 10 years old. We'll just say he was about 9. Right? And Gauss, he grew up in a time where only 2 types of people got to go to school, either the wealthy or the talented, and Gauss fell into the category of being talented. And he was actually a strain on the teacher because he was able to learn and understand and just grasp these mathematical concepts just phenomenally well. And so the teacher to give his other students a chance to learn the math lessons, he would give Gauss a busy work, right? And so and again, Gauss is 9 years old, and if you know any 9-year-olds, they're not very intellectually impressive. Most of them they like turtles, and probably most of them are scared of the dark. And again, we're not talking at a very high intellectual level, but Gauss at the age of 9 was told by his teacher, he was given these assignments to do to keep him busy, and the assignment he was asked to do was he was asked to add together the first 100 numbers. Right, so 9-year-old, he was asked to add the first 100 numbers. So he figured that the number 1 plus the number 2 plus the number 3, all the way up to 98, 99, and 100. He figured that that these numbers must add up to something. We'll just call it S for some. Again, 9-year-old. So this 9-year-old who becomes one of the most influential mathematicians ever, they just see things that we don't see. So a 9-year-old decides that he can make a pattern out of this. And so what he's going to do is he's going to take this and he's going to reverse the order. So he's going to have 100, and then 99, 98, all the way down to 3, 2, 1. And this again is going to add it to some unknown value. So we'll call it S for some. You got a 9-year-old, right? So he switched the order of the numbers because he had an insight. He figured out that if he switches the order of the numbers and adds them together, 1 plus 100 is going to give me 101. And 2 plus 99, that's going to give me 101. And 3 and 98, that's going to give me 101. And then the pattern is going to repeat all the way down to here. And we already saw that 98 and 3, that adds together to 101. And then 99 and 2, that adds together to 101. And 101, that adds together to 101. And then these two guys together, that's 2 sums, right? So this 9-year-old kid realized that if you arrange the order in such a way and add them together, you're going to get a repeating pattern. And in fact, you actually have 100 of these, right? So you have 100 101s, and that's equal to twice the sum. And if you divide both sides by 2, you get that the sum is equal to the number of numbers you're adding together times 1 more, and then you divide that by 2, and that's what that equals to. I wonder what the teacher thought when this 9-year-old figured this pattern out. I wonder if he was just beyond impressed or annoyed. But let me stop talking about Gauss like genius and talk about why this story is relevant to this lesson. And I like this story because it's a real easy way for me to get students to understand that you can add equations together, right? So when I'm talking about solving by elimination, I'm talking about adding equations together, okay? And again, as an 8-year-old, 9-year-old, 10-year-old, Gauss had this very well understood. Oh my God! I mean, he's like this. I mean, that's phenomenal. You just appreciate this, and so I hope this mythology about him is true. There'll be no way to ever know. All right. So remember, Gauss showed us that we can add equations together, and so our goal is going to be solved by adding equations together. So our lesson is going to be pretty easy. And let me get into that. And I just erased the wrong thing. I wanted to erase this. Oh my gosh. Alright, so let's see. I have the equation written down over here. I'm sorry. Alright, so we're going to use Gauss' idea. And so Gauss showed us as a 3-year-old or 9-year-old that we can add equations together. And so we're going to add these equations together. Alright, so let's see here. So using this idea, I can add them together, the x's will cancel. You have $4, so you owe $7, that means you still owe 3. And then so you have 4, you owe 25, that means you owe 21. And when you add the equations together, you know that you're doing it right if one of the 2 variables cancels itself out. And so now we just solve for y. Now, in this particular problem, the x canceled. In the next particular problem, maybe the y's canceled, right? You just kind of have to understand where the problem's going to go. We can now isolate the y value by dividing out the -3, and y is going to be equal to 7. So now what I need to do is I need to use the 7 in either equation. I like the top equation because the numbers are smaller. All right. So now I can find my my x value because I know my y value. So I have 3x plus 4 times 7, so it's going to be my 28. And that's equal to 4. I subtract the 28, and I get 3x equals to negative 24. And so that means that x is going to be equal to, if I divide both sides by 3, x is equal to negative 8. And again, I'm finding where these lines cross. These are linear equations. And so my answer has to be an ordered pair. All right, and again, the story I told you was just a way for me to introduce the fact that we can add equations together. The second equation that I like to do real quick is going to be 7x plus 2y, and that's equal to negative 7. And the other equation is 6x plus 2y, and that's equal to negative 4. Now, in this problem, if I add the equations together, nobody cancels. I'll have 13 x's and 4 y's. So the second type of problem that we're going to see today is that we're going to see that if nobody cancels, like this problem where if someone cancels, we added them together, we can actually change all of the signs of one of the equations. I like the bottom equation signs to be changed because, I'll be left with positive numbers. So I'm going to make u negative, and u positive. Remember, change all the signs of an equation. All right, so now the y's cancel. I'm left with 1x is equal to, I owe 7, I have 4, 1x is equal to negative 3, x will be equal to negative 3. So now, just like the previous problem, I use this in either equation to find my my other variable. And so this is legitimately the assignments today. So either someone's gonna cancel nicely, or you have to change the signs of one of the equations. But this is all I'm asking you to do. And so again, let's make sure that we're doing all that we need to, and we finish strong. Again, I hope everyone's doing okay out there, and I will post the next video on Friday. So have a good day, everybody.